Hi, everyone. Thank you so much for joining us today. My name is ElixirKenya. I'm a software developer. My current stack is Elixir. I work at Color. It's a tech company. Yes, and I'm excited to see all of you. So just a few things. Please keep your mics muted when you're not speaking to avoid any interruptions. We are recording these sessions for those who won't be able to make it and for future learning purposes. In case we face any technical difficulties, we promise to recover as soon as possible. So it's a privilege for me to introduce our speaker for the day. He goes by the name John Daniel Trask. He's known to most as JD. JD is a software developer and an entrepreneur based in New Zealand. He has a deep passion for software as well as business and enjoys exploring both areas. He's the co-founder and CEO of Raygun. Raygun is a leading software diagnostics and monitoring platform, which puts him in a unique position to give the talk for today on performance. Some of his notable achievements include Microsoft MVP for 11 years. He also won the High Tech Young Achiever Award for New Zealand. Then something else, he was his university's Alumni of the Year for contributions to tech. For fun, JD likes to play StarCraft 2 and spend time with family. Without much further ado, JD, welcome. The floor is yours.
Awesome. Thank you very much. And I really love the opportunity to speak with everybody here tonight. I thought I'd start off a little bit by explaining. So where I'm based, I'm in New Zealand. It's 12:08 a.m. So it's the start of Saturday morning now. And we were chatting earlier. It's like, oh, that seems late, but I really wanted to do this. One of the reasons I wanted to do it is because I do a lot of talks with folks in the US and whatnot. And, you know, the world is pretty US centric, right? So often when I talk with Americans, they don't even know where New Zealand is, or they think it's where Australia is at best. And I thought to myself, you know, what I really like about this call is I like the fact I'm doing this with some folks in Kenya. You know, because I'm sure you have that same challenge, which is you talk to some folks overseas and they don't really know where it is, or they don't really know much about it. So we share that in common. And the thing that is sometimes surprising is just how much innovation and how much really interesting stuff is actually happening all around the world. You know, it's very easy for it to be focused on what's happening with the US or maybe with the big tech companies or whatnot. But really, software development is just so cool. And so before I jump into the actual presentation, I thought I'd tell you a little bit about myself. So we were chatting earlier. I started programming when I was 9 years old, which makes me sound really smart, but I can assure you I'm not really that smart. It was a case where we finally got this computer. It was a 486 SX25 with a 213 megabyte hard drive and an 8 megabytes of memory. Windows 3.11, Microsoft DOS underneath. This would have been about 1994. I think we got it late 93. And I mentioned I was literally going through every command that Microsoft DOS had, and I got to Q, where QBasic lived. And that was basically like a notepad like DOS app, and you could write code in there. It was quite simple, you know, a little if statement, print this on the screen. And I immediately fell in love. I was like, oh my goodness, like I can control the computer. And I'm not sure about you folks, but as a child, I was really into Lego, building things with Lego. And to me, I felt like discovering programming was like finding a box of Lego with an infinite number of pieces in it. Like I could build whatever I wanted, but the only limit was what my brain could come up with. And obviously in the mid-90s, computers were not that powerful. And so everybody was pushing the limits and trying to squeeze out as much performance as they could. And I don't know if that's why I've always been fairly obsessed with performance with software. So for example, these days, I don't actually write much code at Raygun anymore. The company's gotten too large for that. But I do write code at home for fun. But I still enjoy things like learning how to optimize some assembly instruction to make something quicker, or looking at general purpose GPU programming to accelerate, very parallel problems. But I've always just had a real obsession with almost efficiency. How can I get it to do more with less? And ultimately, this has led me to build this company called Raygun, where we sell these tools to help people make their code do more and get more out of it. So today, Raygun is headquartered in Wellington, New Zealand. We do have offices in the United States. I literally lived over the road from the Amazon headquarters. Never managed to see Jeff, but it was a pretty cool experience. We have some employees around the world. We're looking at hiring more remote as well over time, especially as the pandemic hopefully starts to subside and we can travel a little bit more. But Raygun kicked off and we started getting these massive companies using our products. So we had Microsoft Azure as an example. They ran their entire public website through our platform to monitor performance. We actually have parts of Amazon behind the scenes running on Raygun. Every single person in the world who watches HBO streaming services, that data flows through Raygun. So we've monitored for HBO alone the performance data for 87 million concurrent viewers of the Game of Thrones finale, if you've watched that series. And so I'm always challenging my own software team as well. How can I get more out of less with our code? And it's interesting actually, I guess, because as I understand it, Elixir is a high performance language. Erlang underneath was built originally for the whole telecommunications environment, which was all about performance. And so I'm hoping that you've come along today because performance is near and dear to your heart. And where this gets really interesting, and I'm going to be focusing on Core Web Vitals today and taking on a little bit of a walk through that and why it's important. But the thing that's really cool about Core Web Vitals, and I'll get to the why soon, is this is going to be creating a business imperative for software developers to put more attention on the performance of their web applications and websites. And what I mean by that is oftentimes as software developers, it's really difficult to build the software that we build. It's very complex. We don't have projects that finish early. They always go over, and we always want to do more work to make them better. And we often run out of time, right? Well, now there's going to be a reason for businesses to say, actually, we want you to make it better. So let's dive into how that's going to happen with this presentation here. I am going to be using Raygun occasionally, probably a little bit more than occasionally through this. It's not a sales talk though. I don't expect everybody to go and buy Raygun today. But if you are curious about using it yourself, I'm not sure if members of your program are involved in this, but if you go and use the GitHub Student Developer Pack, which is free for students, I believe, around the world. Raygun is actually included in that for free for a year. The cool thing about this program, if you're unaware of it though, is that it has software and services from hundreds and hundreds of companies here for developers. So if you're looking to learn stuff, go and check out the GitHub Student Developer Pack. If for whatever reason, you can't use the program here and you'd just like to use Raygun for a home project, shoot me an email or a LinkedIn message. I'll be happy to set it up for you. Anyway, back to the actual presentation. So we're going to be covering today, like, what is Core Web Vitals and why do we care? How we can look at that a little bit with Raygun. I'm going to be talking about that in terms of other tools as well, in particular some free tools, so you can get some snapshots in there. Common problems that impact these metrics, and then we'll have a little bit of Q&A as well on the end. Now, I did check out that I really liked that the website. What was it called? Slido. Looked really neat. I also have some questions from when our team ran a webinar on Core Web Vitals recently as well, just to help seed the questions if we need it. I know we have 1 hour booked. What time would you like me to stop talking? Because My wife and everybody at work will tell you I will just keep talking if you let me. So, is there a time you'd like me to wrap the presentation?
In 44 minutes.
All right. Okay, let's do this.
No.
Okay. So I mentioned from Raygun. This is our website. Here, you come here. We sell a range of products. All right. Charts, things, monitoring tools. We're all used to that sort of stuff. We're helping companies around the world at the moment with Core Web Vitals. Part of that is how do we make sure that people can understand the performance of their software, and then when they realize there's places they need to do some work, how can we help them very quickly identify where those issues are so they can fix them quickly. We'll ignore the poll part. Let's jump in here. So Google's Core Web Vitals is effectively 3 different metrics. There's largest contentful paint, first input delay, and cumulative layout shift. We're going to dig into each of these metrics, so don't worry too much if you're thinking, oh gosh, what are these things? But why they're really interesting is you may know that pages have a load time. You know there's a time to interactive, there's the document is ready event, all of that sort of stuff. But these 3 metrics are much more focused on the user experience. So the impact to you and I as users of a website. And Google have taken these 3 metrics, and what they've said is they're going to be incorporating them in as signals to the search engine rankings. So Google has, for a long time, nobody really knows how Google actually orders the search results. And to be honest, my hunch is that these days it's probably all machine learning and no human probably does know exactly how it happens. But they used to say that they had more than 250 signals that would go into helping rank a particular position in search results. You're probably aware, but there's a very fast decay in the click-through rates on search results. So the top result might get like 80% of the clicks, the second result might get 10% of the clicks, and it just falls off very quickly. So there's a very aggressive battle that goes on to try and sit high in the search results. What Google have said is, we're going to take these metrics, and if these 3 are not looking good, we're going to send you right down the search results. And so this is the mechanic that's starting to play in, is saying, look, as software developers, we've always wanted to make our software as fast as it can be, but we often couldn't actually argue with the business to allocate the time and money to making sure the performance is good. I can tell you, as a chief executive officer, if my business starts losing a whole lot of traffic, and I find out that it's because our site doesn't perform very well, I'm going to spend money with my development team to make the site faster. And so this has just started rolling out literally this June from Google, where they're starting to use these metrics. They're starting by collecting it only from mobile devices, but later this year, they'll also be incorporating these from desktop as well. Like I say, don't worry too much about the metrics themselves at this point. We're going to dive into them. You'll see here, though, that 2 of them, largest contentful paint. This is really what is the biggest thing that gets drawn in the browser above the fold when the page is loading. It could be a big hero image. It may not even be a big image. It could be in terms of it could be a relatively small image by file size, but stretched out as well. And so they're looking for the time that it takes for it to complete the largest element of drawing for the website. First input delay is measuring how long does it take until the user can actually begin to interact with this website. So you may know that if you put JavaScript in the head tag and it slows down the website from loading, the main thread of the website is busy getting things ready. You sit there with your mouse and you, come on, well, I want this to respond, and you're sitting there. It's very frustrating when a site doesn't seem to want to interact yet. So they're measuring that. And then the one that I like the most personally is this cumulative layout shift, or CLS. Now, this is not a time. This is not 1 second or 2 seconds. What this is actually measuring is how the page lays itself out as it's getting ready. Now, I'm sure all of us have been on often news websites and the similar that have lots of ads and things like that. And it's really frustrating watching as the web page just, janks around all over the place while it's getting ready. Twitter search, yep, bang on. It's frustrating. Now, this is exactly why Google is incorporating these metrics, because they know that if websites are frustrating, users don't have a good experience, they might not really want to be on that website. So we're going to dig into that one quite a bit because it's super fascinating in there. I'll jump forward. So why do we care? This is a really interesting topic because there is some really great data out there, but not a lot of software teams use this. And I don't blame the software teams for this. I genuinely, if I had to blame anybody, I'd blame the executive teams in companies for not understanding enough about software and the impact of it. So the examples that we've got here is, and I'll just read these out, but Vodafone improving their largest contentful paint metric by 31%, increased sales by 8%. Now, I can tell you, trying to drive 8% growth in a business is not normally as easy as making your website a bit faster, but this is the impact, is that every single second of performance lost in a website is actually costing that business significant revenue. You've got some other data in here, for example, saying they had an 11% improvement in the cart to visit rate, meaning 11% more people are interacting with the purchasing cart just because the site got faster. And this was actually a really big thing back in the day with Amazon when it launched originally in the 90s as well, was the site had to be really, really quick. The faster the site, the better it converts. And it's quite hard to explain that to people because we all know we like things to be fast, but it's very difficult to actually quantify the impact of us liking things to be fast. Where this gets interesting is that Google have been talking about incorporating Core Web Vitals now for several years. It's really just started to get rolled out, like I say, this month. And this measure here should be terrifying to a lot of companies, which is to say 87% of e-commerce companies' websites are going to go down the rankings for having bad performance. If you're an e-commerce site, and you're falling in those rankings, that is direct revenue loss for that business. And this is where us, as an all-star team of software developers who like to write fast code, we can start saying, hey, we can fix this. And it's the sort of stuff we love to write. By the way, we don't have to wait right till the end for any questions. If there's anything that pops up as we go, please use the chat in Zoom or unmute or put your hand up. I'm not one of those let's just wait for the end kind of people. Like a conversation. So feel free to sing out. All right. So ultimately, we're trying to make it so that the web is much more enjoyable for everybody. We're trying to help the developers so that we can make things fast. We need to work out where we prioritize our effort. And ultimately, we're going to make our website go up in the search results and everybody's going to be happy. So I'm going to go and show you how we do this today with Raygun. Now, we sell multiple products. The one I'm going to be demonstrating a little piece of today is called Real User Monitoring, or RUM, like the alcohol. And so RUM is actually a category of software. Now, I didn't actually know this when I was probably in my 20s, before we built our company around this stuff. But Real User Monitoring means we are now measuring the performance that the end user experiences, real human beings. So we're measuring, for example, we might want to understand how Emmy is experiencing the website, how that's loading for her, that sort of thing. Now, this is an interesting topic because there's a lot of tools out there in the category known as synthetic tests. This is where you might go and ping a website, measure the time, and it will tell you a number. The thing is that synthetic testing or automated testing like that, it's not actually representative of what your end users are experiencing. So for example, if I was to ping a website and get the data back, that might only be going through my fiber connection. I've got a pretty good computer, might be a server up the road. But what I'm missing out on is not every user is always hitting a website with that sort of configuration. Sometimes we're on an old iPhone 6, and we're on a hike and the internet connection is really bad. And so it performs poorly. So real user monitoring is about understanding how do our actual users experience it by tracking the data from within their browser and sending it back. So I'll just jump over here. So Let's bring this up here. So this is Raygun Real User Monitoring. I've set the time period to a month in here. And what we're doing is we're looking at the load time. And this is actually, because I like to be vulnerable with everybody, this is the data from our own blog. And you'll probably look here, if this is the load time and we're seeing things at 3 to 4 minutes at the P99 level, which I'll talk about in a second, that's probably a pretty bad experience. I don't often want to wait 3 minutes for a web page to be ready. I'm probably going to leave. Okay. Now, what P99 means, just quickly on this, is rather than say an average number, we're saying what is the 1% slowest time that this took to load. So if I took all of the users who hit this website and I ordered them from fastest to slowest, what was the 1% on the end that had the worst experience? And so that's what the red line is here. This is saying these are what the last 1% are experiencing. And that looks horrendous, right? If I turn that off, we start seeing numbers down in about the 30-second range, which in this case is the last 25%. That's still not very good. I'm going to want to make this, oopsie, that's the last 10%, sorry. I'm going to want to make that better. So we can also, you can see here, we've now got these Core Web Vital numbers in here. What's our time for largest contentful paint? Now there's an outlier in here that makes that difficult to see, but we can see we're looking like we're sitting roughly around 5 seconds. So 5 seconds for the largest thing to be drawn on the web page here. If this is not making too much sense at this point, that's okay. We're going to dive deeper into a single web page and have a look at that. So let's go and have a look at one of these. We're going to look at this blog post here. And just so that we understand what we're looking at, I will just open this up in another web page. So this is the blog post here. You can see there's quite a lot of text in this one. Oh, there's a really big graphic in here. Something tells me that this may be associated with our poor performance. But let's scroll back up and we'll jump back over here. And so now that we're looking at the data for this, let's have a look at this chart. This is this is a histogram. And what it's doing is it's looking at all of the users who have hit this web page, and it said, how long did it take it to load across the bottom? So this is an interesting way to think about that last 1%, the P99 in here. It's saying the P99 just for this page is 2 minutes and 50, it must be 2.51 minutes rather than 51 seconds. That could be a bit better. But like we always expect, we've got most of the stuff at the front here. If we scroll down to Core Web Vitals though, so we've recently added in this module to tell us about these 3 key metrics, because believe it or not, the load time is not really that important anymore. You may know from writing some JavaScript that the idea of the document being ready or the page being loaded, that time can sometimes move around based on all sorts of random factors. So it's no longer considered a particularly good measure of when a website is ready, which is partly why Google have introduced these 3 metrics. So if we come down here at the Core Web Vitals, we can see our largest contentful paint. Remember, I estimated it was around 5 seconds. It looks pretty accurate. We've got 16.9 milliseconds until the user can interact with the page. That's not too bad, but we could possibly be doing better. And then this cumulative layout shift. Like I say, this is not a timing or a percentage. It's a little bit difficult to follow, but if you have a look here, you want to be under 0.1. Now, there's a whole lot of tools out there that will help you visualize how the cumulative layout shift gets computed. It is quite complicated. I would only look at the math if you're really, really interested in it. So just a heads up on that one. And then you have these 3 ranges. Good. So that's the green. We have the needing improvement range, and then we have poor. And so what happens is Google is looking at these numbers and they're saying that they want to see as many as possible being good, but they're not being super harsh. They understand that nothing is usually perfect. So it's a case of trying to meet a generally good standard to help yourself. You don't need to be trying to get the entire bar green, because sometimes when things are slow to load, it's nothing to do with the code. It could be the connection. like I said earlier, it could be an iPhone user on an old device on a poor connection. You're not going to be able to make that fast no matter how well you work on the code. And so we've started to put this in because we're getting more and more and more customers who are saying, hey, we need to get in front of these changes to make sure that Google's changes don't impact our business. I mentioned earlier, but it's worth a quick refresh on. At the moment, what Google is doing is they are only looking at the numbers from mobile devices. So they're not actually computing this from desktop Chrome. They're looking at the mobile users. So when you're doing your own testing and wanting to see how your websites are performing, make sure at the moment that you look at the mobile numbers, not the desktop ones. They are going to add desktop numbers into the mix later this year, but it's not there yet. For our demo purposes today, we're going to stick with all. One of the things that is actually quite cool about Raygun, sorry, I am quite proud of our own products from time to time, is, well, actually, let's be very clear. Nothing tests our software better than when I'm demoing it and something then goes wrong. That happens all the time, right? As a sidebar, we started our business by selling software that actually collects software errors and helps businesses understand those. I can tell you that there's a lot of software errors in the world. We process billions and billions of them every month, and nothing has made me feel more at ease with when I have a software bug than just looking at the data flowing through our entire platform is going, oh no, everybody's finding software quite complicated. Anyway, that was a bit of a tangent. Is that you can actually jump in here and we could say, okay, well, let's try and figure this out. And now I think this is a slide coming up, but I'll just keep going. Why are some users having a poor experience with largest contentful paint while some are having a good one? It's a good question. As a software developer, I'm wanting to fix this problem, but how do I go about fixing it? Let's click on the poor one. I can actually drill in here and I can see all of the users that made these requests. I can see their browser, their operating system, and their location. Now, one thing that stands out to me here is there's a lot of Chrome in here, right? There is Edge, but I'm sure you're familiar. Microsoft have actually adopted the Chromium engine into Edge, so it's effectively Chrome as well. Raises a really good point. At the moment, all of these Core Web Vital numbers are only calculated in Chrome. Google has put it into Chrome. It's not actually a feature of Firefox or any of the other browsers. It's only in Chrome at the moment, or Chromium, I should say. So it is also in Microsoft Edge because that reuses the Chrome core. I expect that will change. One of the things that is beneficial about that at the moment, however, is that Google, they are making a lot of adjustments, particularly to that CLS metric and how they compute it. And so because they are sort of in control of the whole browser market there, as they evolve that, it will just evolve for all of us and work quite well. But that's why we're not seeing any, let's say, old Internet Explorer or Firefox in here. Only Chrome has these metrics. Looks like a pretty good spread of Android, Windows 10, Mac OS, Linux. Okay. I'm definitely noticing a pattern though in the countries. There's a lot of traffic here from India and they seem to be having a poor experience. Let's go on and have a look at why they might be having poor experience. So let's go and have a look at this particular session. We can see that this user, they only hit one page on our website. It took 11.3 seconds for the web page to load. That is relatively slow. And they looked at it for 1.2 minutes. Still really not enough data for me to diagnose what's going on. So I can click through here. And this is actually giving me, for this user, for this exact request, the entire waterfall of every asset and how long everything took to load. So I can kind of go from that 30,000 foot view right down to how long did this particular user take to load up our font file. Now, you can see here in this timeline view, a lot of the time here is going into transfer. So these fonts, for example, I'd have to go and have a look at how large they are in terms of kilobytes, but basically 6.8 seconds to transfer that file. This is an example of what I was saying where I might not be able to fix this as a software developer, because what I think I'm going to find here is that there's just not great internet connectivity for a lot of our users in India. How can I make that faster? Now, there are options. We could look at things like maybe, is there a local Indian CDN or some other type of technology play where we can bring some of this data closer to those users? Or is it just a case that the internet infrastructure is not quite up to the level that it is in the rest of the world? I'm not sure. I don't know. But I already now know that most of the time is going into transfer time, and that's going to be difficult to fix. I may want to encourage my team to reduce the number of fonts, because we've got 6 in use here, and they look like they stack up. We might want to tidy that up. So that's one way we might look at that. I'm going to just jump back to the slides now for a second, because I'm probably running way ahead of myself here. We're going to have a quick look at what are some of the things that really impact these scores so that we can look to fix them. Sorry. Yes?
Yeah, I have a question on that.
Sure.
Yeah, so looking at that kind of data and information, it actually, I would like to know, is there an API that is exposed by Chrome to Raygun, or are you using this through JavaScript, or how really does Raygun have access to such kind of information on a user's browser?
Yep. That is a really great question. I will show you. Let's go and view the view page source. It is JavaScript. So the thing with real user monitoring is that in order to actually measure it best for the user, you need to be able to capture the times from the user's machine, which is kind of, I guess, what your question is how are you getting this from their machine to you? So we have a small block of code. It looks very similar to the, this is actually it here. Maybe I can zoom that in a little bit. That's all you really need. And that'll actually pick up and report any of the errors, as well as the Core Web Vitals and other performance metrics. And so what this actually does is, because we don't want to impact the performance negatively for our customers, all of this mess of code here is actually saying, okay, if any errors occur before the script is loaded, stick them into an array and just wait here for a while. This piece down here is saying, load the Raygun JavaScript file off our CDN, which we use Amazon's CloudFront, which is pretty global, pretty good. When that gets loaded, but we load that asynchronously later in the page because we don't want to contribute to the slowdown in the website. And when that script gets loaded, it goes and looks for any errors if you're using our crash reporting and sends them off. And then it goes and sends off the performance data. The performance data itself, and I'll tell you what, I'm really going to embarrass myself here. If I bring up the console in this browser, if I go, actually, let's go performance timings Chrome console. I'm going to demonstrate that no matter how senior you get at software development, your key skill is being able to Google the answer to things. But I wanted to grab something in here. Yeah, this is it. Because it's quite cool. This kind of blew my mind when I first sort of came across it. Performance.timing. Yeah. So if we go performance.timing, let's just see what that spits out. Yeah, cool. That worked. Brilliant. I hope that's readable. I know it's a little bit probably small and dark on there. But what happens is Chrome, every time you hit a different web page or load anything, it actually does store a whole bunch of performance metrics that are available in JavaScript for you to pull. So in this case, you can see in this one, we have the loaded event, when it started and when it ended and when the request started and when it ended. And if we got a redirect, say a 302 redirect, how long did that take? And so this data is actually always sitting inside of Chrome. And you can just write JavaScript to pull these values out, which is in effect what we do. And then we send it off to the Raygun API in the background that way. The other thing that's kind of worth noting here is that Chrome actually is reporting not all, but it's reporting this data back to Google all the time, right? So this is the thing. How is Google going to know what everybody's site performance is like? Well, because they're basically snooping on all of us because they control Chrome. And so they know those numbers. That's already coming through. Yeah. And so when we get to some tools later, and you're wondering, okay, well, how are they getting it if they don't have the JavaScript? The answer is it's from samples from Chrome. And so Google actually does have a service, I think it's called the Chrome, well, I think it's CRUX, Chrome User Experience, where every month they actually make a huge database of this timing data available for everybody to query so that we can look at trends across the whole internet over time around performance. So yeah, it's quite cool. Does that answer your question, Sigur?
Yeah, sure. That was clear. Thank you so much.
Ace, cool. All right. So we mentioned largest contentful paint, and so this I think it's pretty understandable. But we can look at this as like the browser is blank. We get a first paint event is like it started to draw anything. First contentful paint means usually the text. So what is the content of the HTML? And I start putting that on the screen. And then the largest contentful paint is usually the largest image, as I mentioned earlier. So the common thing that you'll have an issue with there is when you do put a large image on the page. The thing where this gets complicated as well is obviously sometimes people look at things on a mobile phone. Sometimes they look at them on a jumbo 4K screen. Sometimes they look at them on their old 486SX25 that they might have restored. There's a lot of different things here to think about. And we're going to look at ways that we can use modern technology to overcome those complexities. So in here, we mentioned you can go in with Raygun. You could look at the timeline chart. You can do this directly with the Chrome Web Tools. I did mention that this is not a sales talk. Just pivots on some of the stuff here. So there are free alternatives. So some of the things you want to do with this is obviously make sure your images are as compressed as possible, but without losing too much fidelity. And then one of the more modern things here that I suspect you already know, but wasn't the thing when I was first doing web development, is you can set up source sets with images. And this allows you to say, hey, I've got an image tag, but based on like the screen DPI, go and load this one or this one or this one or this one, so that you can cater the content to the platform that's actually making the request. So for example, if it's a mobile phone, you may actually be able to fetch a lower resolution or smaller image to make it so that this is not so delayed. It does mean you're having to put in a little bit of work to have different sized images and things for different platforms, but the browser is smart enough to make the request that makes the most sense for the platform it's on. So that's one way to work, a way to improve that there. Cool. First input delay. So mentioned the browser has a core thread that does the rendering, right? And this means that anything that we do on that core thread within the browser is going to block the ability to interact with the web page. To be honest, I don't often see many websites that have a lot of delay on being able to interact with them unless they're really, really spammy websites, or maybe I'm finding a torrent for one of those Marvel films we talked about. There's stuff in there that makes the website really slow. What's interesting is back in the day, Amazon, we'll jump in here. So before we had Core Web Vitals and all these monitoring tools, what Amazon used to do when it was measuring its own performance was that they would only track when was the search bar visible and the user could start to interact with it. They didn't care how long anything below that search bar took to load, because they knew that most people, when they arrive on Amazon to buy products, are actually first when they land, they're wanting to type in a search to find the product. This is a very similar type of metric. When can the user actually begin interacting with my web page? And so most often the things that impact this is actually JavaScript files that you want to take out of the website. And while I absolutely love our friends in the marketing department, marketers quite often like to put JavaScript files into websites, and they don't often fully appreciate the impact that that can actually have on the performance. And so that's where a software developer may come along and go, you know, that Adobe script is adding 4 seconds to every page load. Do we really need that data from that? That's, I actually think, is another reason that Google is pushing this, is that marketers absolutely pay attention to search engine rankings. Software developers, we don't really, but now your marketing folks are going to have this compelling reason to want to make sure their website is fast as well. Cool. First input delay. Like I say, you can resolve this as well with things like code splitting, breaking up your JavaScript so it's smaller to load. Because, for example, when the browser is actually parsing the script and building the I guess the abstract syntax tree or AST for that file, that takes time off the main thread. Stuff is going on as the browser's getting ready. Minifying files, and then also reconsidering just how many different scripts you're actually loading on the page and whether we can get rid of any of them. That's a big one. This is a good example of the cumulative layout shift that the team put in here. We've all been on websites like this. In fact, I found an even better video that really highlights the frustration of this. I think it was this one here. We've all been on a site like this, right? Where it just renders something as we go to click, and you're like, what is this? This is terrible, right? This is exactly why it's user hostile to have the website moving around a whole lot. It's very, very frustrating. And so they're trying to get people to stop doing that. So really common, this one is like the easiest fix of them all, really. Making sure that when you put an image tag in, you actually put the height and width tags on there, because that means that the browser, when it even fetches the HTML, it already knows how much space to allocate for the image, so it won't move any content around, even though it doesn't actually have the image yet. If you don't have a height and a width on an image tag, it actually has to have started downloading the image to figure out what the dimensions are, which is why it causes this late stage movement in the page. So height and width, that's a really easy one to do. There are situations where there's just no space being reserved, so things move out because of that lack of a height and width. The cumulative layout shift. Now this one, anyway, we'll skip past that one for a second. Sorry. We do this one actually does overlap with the prior one, so the height and width stuff, but also just being mindful of how many things with JavaScript are kicking off and doing things within a web page, right? Because this is often what can happen. We've all seen those websites that pop up, you know, in the bottom right hand corner with a little chat widget, and then on the other side something else slides out doing stuff. It's really annoying. There's a website here in New Zealand. It's a news website. It's called stuff.co.nz, and this website, I think, we'll see how it goes, if it even loads. Maybe let's try it again. Well, as you can see, it doesn't perform very well. So we'll keep moving. It didn't even load. Let's jump through here. Okay, I don't actually want to answer this question yet. I'd like to talk to you a little bit about some of the other tools in the toolbox that aren't Raygun. So a couple of things that you'd want to have a look at. Google page speed insights. So you can just Google page speed insights. You'll get this website. We can put things in here. So if I go and check raygun.com, now, it takes a little while. It's going off. It's having a look at the web page, and it's going to come back and it's going to give me some scores. Now, full transparency here, we actually have a lot of work to do on our own site to make sure that it meets the bar for a lot of Core Web Vitals. Now that we know what to measure, we can make it better. So this does take about 45 seconds, but it's pretty useful. Close that tab. If it takes too much longer though, I'll jump to another tool. But this is free, does come from Google. Oh, come on. One thing that is interesting as well as part of Core Web Vitals is that Google themselves are actually getting given a little bit of a hassle, because some of the slowest scripts on the internet are their ad scripts. that they load on your website. So yeah, it'll be interesting to see what they do there. Come on, this is like a Microsoft progress bar, isn't it? It's never going to get to 100%. Okay, maybe while that sits there doing its thing, I'll show you another thing. Let's go over here. Yeah, so I've already done this one. Is everybody familiar with the built-in web dev tools in Chrome? I can only see a couple of people. There's a couple of nods. Cool. So if you go to a website in here and you go along to, I'll reload that. Cool. And so I'm using Microsoft's Edge, which, like I say, is Chrome-based. So this is exactly the same inside of Google Chrome as well. There's a Lighthouse tab in the Web Dev Tools, and if you click on that and then you go Generate Report, you'll see that it jumps around over here and it's simulating loading this web page in all sorts of different devices and connection types. I think this is in effect doing exactly what this tool was doing behind the scenes. So you can see here it's impersonating or pretending that it maybe is on a 3G connection that's old and trying to give you a rough idea. Google themselves do recommend that if you're at you are a business, you should be using a real user monitoring tool to get the broadest amount of data you can, rather than just one-off hits with these sorts of tools. But they are pretty good as a developer when you're just trying to sanity check roughly where am I sitting. Well, that one's just stuck at 99, so I'm going to come in here. This was one I loaded earlier because whenever you do demos, you can count on them not working when people are watching. So this is actually one of the pages that is on our, I'll come to that question in a sec, thank you. This is one of the pages on our blog, and you can see we're getting the score of 37, and it's saying, hey, this is not going to pass, therefore this page on our blog is probably going to fall down the rankings as Google ramps up their use of Core Web Vitals. And you can see here, very similar to the UI that we brought into Raygun itself, we're failing on the first contentful paint and the largest contentful paint, but we're actually doing really well on the first input delay, and we're also doing really well on the cumulative layout shift, probably because we don't run ads on our website. But we need to go and have a look at maybe how many graphics we're using. We probably need to look at that source set stuff that I mentioned. And I'm guessing we must probably be doing the height and width right, because the cumulative layout shift is looking okay, but we've clearly got too big a graphics on one of these pages. So if we go and have a look at this now, let's jump over here. Now, I have actually zoomed in my browser, which is why this looks so alarmingly huge. But yeah, we can see there's quite a few graphics on this page that are coming in here. So that's probably the biggest contributor. By the way, afterwards, if you are looking for more content around Core Web Vitals, do feel free just to come over to our blog. We have written quite a bit of stuff over here as well. See if this is finished. Cool, it has. So Lighthouse has gone through and it's looked at this, and you can see we're seeing numbers roughly what we expected to see. Yeah, something's definitely going on with my computer at the moment, but we're rating pretty well for accessibility and best practice in SEO, but performance itself is a bit poor. This was hitting the main website, the main homepage, which has a lot more graphics and animations and things in there. But yeah, jump in, have a look at the Lighthouse tab within your Chrome DevTools. You'll be able to check that out. So we'll jump back to the question here. How much bandwidth does your JavaScript file use? I assume it sends a lot of info to your backend. How expensive is this for the end user? That's a really great question. I actually do not know off the top of my head how big that file actually is now. So let's see if we can go and find out together. Fundamentally, though, we'd have to put quite a lot of work into trying to make this as small as possible. I'll just save that as, I'll just put it on my desktop and we'll tell you. Let's see what we've got here. Cool, so it comes out at 64 I don't know if that's appearing over there, but 64 kilobytes basically in size. So that's not tiny. It's not huge. The thing to remember though is because JavaScript files are also plain text, there is compression that occurs on data transfers by default with gzip. So probably over the wire, you're looking at a few kilobytes. In terms of the data that gets sent to Raygun, with the Rum product, it's pretty lightweight because if you actually look at the requests as they get sent off to Raygun, we've more or less shrunk all of the payload down to single characters for the timings, so that we're not wasting any space at all that we on what's being sent up. We only need to send a little bit with Rum. Where you can use up a lot of data is actually on crash reporting. Now that's because a crash report can be up to 128K by itself. Usually they're about 20K, but I have seen some crazy things in my time. For example, we had a customer at one stage who had an error that was triggered on the mouse move event in their web page. So every time the mouse moved, it was firing off error reports to Raygun. We had a customer the other day who sent us, I think it was 780 million errors a day through the platform. So it can get quite high. However, I don't know if there's particularly high costs and things like that related to data within Kenya, but within the numbers within New Zealand and the US, where I'm familiar with, it would not usually be enough data to be of a concern to the end user with their internet. We do have all sorts of things though. So for example, if somebody is on a mobile, we have options to do things like store it in local storage unless there is actually a Wi-Fi connection. So don't use the cell connection, that sort of stuff, to try and be as kind as possible. In terms of rate limiting, it's a good question. We do have rate limiting capabilities on the server side, and we do advise customers on how they can do rate limiting within the browser. The reason that we don't do it by default in the browser is because particularly for Rum, you actually want to rate limit by session, not by page request. And the reason for that is, let's say I hit 5 pages, but we only sent 3 up and I was looking at the user journey, it would make no sense. But we want to say, actually, this user, we're happy to capture their session. This user session, we might ignore completely. So it's just a little bit more coding that we can do with folks for that in there. Keep in mind as well that this script is in effect the script for 2 products, so crash reporting and Rum. So if you wanted only one, you can actually kind of break them apart if you'd like. Cool. We're pretty much kind of coming to the end on just these 3 metrics in the Core Web Vitals bit, and I have 1 minute. So I'm going to start with the question that was asked on Slido, which was, is improving site performance the same as SEO? Now, the answer is, it is now. This is the thing with Core Web Vitals, is previously your site performance was not a significant element of your search engine optimization. It didn't really have a huge impact on your placement in the search results. Now Google is saying, actually, we're going to make it an important part of it. So previously it was more things like the accessibility measures, backlink counting only, all those sorts of things. But now we've got these extra variables in the mix. And that's what's going to make businesses start saying performance is worth an investment, which is really cool. I was going to jump into a whole bunch of other questions that have come through from other people, but I think given the time and that I've run straight into 1 a.m. here, I should open it up. Is there any questions folks would like to just unmute, throw in, or drop in the chat?
I have one.
Sure.
So if I want to use Raygun's monitoring system, I get to add the JavaScript in every script, in every page.
Yeah, so normally the way you would do it is, and to be fair, I've done like that much Elixir in my time, so I don't know, for example, what the common say the view layout languages are in there. But typically what we see folks doing is if they've got any sort of view templating and they've got a common footer or a common header, they'll just put the script piece in the header block or in the footer, depending on where they'd prefer. And then that just loads it on all the pages. Usually it takes, for crash reporting and RUM, so crash reporting for JavaScript and the RUM part for obviously in the web interface. Yeah, talking about a 15, 20 minute setup time to get most of the stuff in there. It's basically identical to what you'd be doing if you were setting up, say, Google Analytics, where you just have a little block. If you signed up for a trial, we would just give you, just seeing if it's in here, actually. I won't go through the setup process, but it has a nice thing where you just say, I need JavaScript to say, paste this block in, and you're all good. It sits there with a spinner and says, we're waiting for data. So it's pretty straightforward to get set up in there. Like I say, though, you've also, at this point, got the Lighthouse auditing built right into the browser and the page speed insights tool as well, if you're just wanting to get a feel for it. Cool. The Raygun dashboard looks awesome. It does. Thank you.
Is there time for one more, or do you have time?
Yeah, well, I've got all the time in the world. My son won't get up for 5 more hours.
So I can go ahead and ask a question.
Sure.
Yeah, sure.
All right, awesome. So so what I've got from this is that Raygun is actually an application performance monitor for the client side. Is that true up to that point?
It is true.
Okay.
We can also do
you have any for the server side?
We do have server side support as well. In crash reporting, we have limited support in our code profiling. That's only with .NET Core, Ruby, and Node.js at the moment for that piece. But crash reporting is pretty much everything. And the thing with RUM is JavaScript covers you for the web. We also have SDKs for native iOS, Android, Xamarin, React Native, and things like that. Because when you're measuring end user experience, like I say, you need to be on the user's device in effect. And so that really means it's either going to be in the browser or it's going to be a native app, right? They're kind of the two types of systems we interact with today. I will say, however, JavaScript by and away is the biggest language we see in use at the moment. I think that is just partly because everything, if you're on the web, you got to use JavaScript. So, yep. Cool. Any other questions before we wrap? I'll tell you a random story then very quickly about the Raygun dashboard. So you see this little lightning bolt up here? When we first built this thing, I really wanted it to be animated. And so it does this like...
There's a question on the chat.
Sorry? Yeah, that was in the chat. Oh, yep, sure. I'll just finish this piece. But the thing that I've loved about this is it doesn't do anything. It just looks cool. And we get customers every couple of weeks going, I've clicked it 50 times. What does it do? And I just enjoy the fact that it bugs people at this point. How much does Raygun impact front-end performance? So that's a really good question, because in effect, no monitoring comes totally for free. What I mean by that is the very fact that you had to put a single character of text into your HTML to include a script, that's going to come at a cost. However, we work to try and make sure that that cost is as small as possible. And so that was where I was saying we have that script block, but while it's not very readable because we've tried to make it small, in effect, what it is doing is it's saying, I'm going to load a JavaScript, but I'm going to wait to load that script until I feel that the whole rest of the site is finished loading. And so you have the smallest possible upfront hit that we can possibly make followed by, if there is some overhead, it's going to come later. So it doesn't block the web page. It doesn't cause an impact on the actual user experience. We were talking about this today with one of our current customers, and I think the number came out at something like 2.5 milliseconds of overhead in total. So it was fairly light. The general rule I have is that the last thing that I want is for the best way to improve your performance is to take out the performance monitoring tool. That should never be the the best way to improve your software. Yeah. All right. I won't tell any more random stories either. So maybe we'll wrap now.
Well, thank you so much. We didn't notice the time moving. I have learned a lot. I'm not going to take height.
Oh.
Yeah, did she freeze?
I think she did.
Yeah, she did. All right, well, she's trying to unfreeze. Thank you so much, John. Thank you for the session. It was actually a very awesome session. Thank you for staying up late. I honestly don't think if it were me, I would be able to do anything past 9 p.m. Maybe you're used to it, I don't know. But we really appreciate the time that you've taken to come and talk to us about this. This has been a gray area that a lot of people don't really consider. And if they do, it seems like the last thing that they think about, and they don't really concentrate on doing it. I don't know if there's any other person who has... Okay, Frank, you have something to say, or you've just typed it in the chat?
Someone tweeted today that it's more important to spend time ensuring that you know when something is broken than to spend time trying to prevent things from being broken. That is a really good point. I guess maybe extending from your point there as well, Sigu, is that it's not a common set of tools. A lot of customers we get, they come from nothing right now. As in they're not monitoring things at all. And so it is actually quite an emerging area of people saying, actually, we should understand where the stuff is going. So yeah, it's absolutely an up and coming space.
All right. Tracy, you there?
Hi,
yes,
sorry,
I'm here.
Back. Oh, yeah, Njoki is back.
Awesome.
My internet decided to act up at the very last end. Thank you so much. We have learned a lot. This was a very insightful session, and we have this recorded, so we can always get back to it. We'll definitely try the Raygun platform. I've seen that there's a trial version before you commit. So we'll definitely do that. So thank you so much. And to everyone else who joined, thank you. I hope you learned as well. Yeah, that's it.
Thank you very much for having me.
You're welcome.
It's been a pleasure. See everybody. If you do want to get in touch, I am on Twitter as TraskJD. Shoot me an email, whatever. Like I say, if you'd like a free account or whatnot to play around with, I'm always happy to help. I always like to help people. So yeah, do sing out. Thanks again. It's been a real pleasure.
Thank you. Bye.
Thank you.
Bye, everyone.
Good night.
Bye. Yeah, I was almost telling John that Nuku is not from Kenya. He's actually from Nigeria.